Hi, this video is an introduction to logarithms. Let's start off with some key vocab. Let's write 8 as the power of 2. So, 8 is 2 cubed. We call 2 our base, and the power, which is 3, we call this the index, or the exponent. So, what is the point of logarithms? Well, let's say we need to multiply two large numbers. I'm going to take the example of 9 times 27. We can write these as powers of 3. So 9 is 3 squared, and 27 is 3 cubed. And we can simplify this to 3 to the 5, because 2 plus 3 is 5. Let's have another example. (64) divided by 60. So, we can write these as powers of 2 to make our lives a little bit easier, and say that this is the same as 2 to the power of 6 minus 4, which is 2. Let's have a look at the powers of 2 more closely. So we know that 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, and so on. Now there's another way of expressing these. We can write this as log base 2 of 1 equals 0. In other words, 2 to the 0 equals 1. So here, you can hopefully see that this 2 is our base, and you can see that our index is on the right hand side, 0. So our next example is 2 to the 1 equals 2. So we can write this as log base 2 of 2 equals 1. And hopefully you can now spot the pattern, because this will be log base 2 of 4 equals 2, and log base 2 of 8 equals 3. Well, you might now ask, what about negative powers? The good news is, you can also write this as in terms of logarithms. So, you can say that 2 to the power minus 1 is a half, and 2 to the power minus 2 is a quarter, and so on. So we just use the same theory here, and we say that log base 2 of a quarter equals minus 2, and log base 2 of a half equals minus 1. So let's do some questions based on this new theory. So please pause the video and have a go at these examples. Okay, so hopefully you've had a go. So let's start off with the first example, log base 3 of 3. So how do we solve this? Okay, well let's start off by writing 3 to the power of something equals 3. Well, we know that this something is going to equal 1. And now we have log base 3 of 9. Well, 3 to the something equals 9. This is 3 squared. And we know that 3 cubed is 27, and 3 to the 4 is 81. So let's say we have 3 to the minus 2 equals a ninth. You know that this will be log base 3 of a ninth equals minus 2. Okay, what if we had something a little bit more complex? Let's say we had 64 to the 2/3 equals something, and we're supposed to write this as a logarithm. Okay, how do you express 64 to the 2/3 in a nice way? Well, we know that 64 is 4 cubed, and we're raising this to the power 2/3. This is the same as 4 to the 3 times by 2/3. We can see that the 3 will cancel, so 4 squared is 16. So we can write this as log base 64 of 16 equals 2/3. Now, I want you to have a go. Can you express root 25 as a logarithm? 27 to the minus third as a logarithm? Please pause the video and have a go. So how do you express root 25? Well, this is the same as 25 to the half. And we know that this is equal to 5. So you can say that log base 25 of 5 is a half, which is 0.5. So next we have 27 to the minus third. We can write 27 as 3 cubed, and this is all raised to the power minus a third. So just like we did in this example, we can say that 3 to the power 3 minus a third is going to be equal to 3 to the minus 1, as the 3's cancel, which we know is a third. So if we express this as a logarithm, this will be log base 3 of a third equals minus 1. Okay, so hopefully you're getting the hang of this. Let's try some challenge questions now. So please have a go at these 4 questions. Okay, so let's try and find the values of these following logarithms. So we have log base 81 of 3. How do you solve this one? Let's start by saying that we know 3 to the 4 is 81. So this is log base 3 of 81 equals 4. But this is not what our question wants us to solve. We have log base 81 of 3. That's no problem. So we can say that log base 81 of 3 is 4 to the minus 1, which is a quarter. Our next example is log base 32 of 2. We know that 2 to the 5 equals 32. we can say that log base 2 of 32 is 5. This is just an equivalent way of expressing that, but we need these to be switched around. So this will be log base 32 of 2 equals 5 to the minus 1, which is a fifth. Now we have a fraction. So it's going to be a little bit different, but it's really just applying the same theory. From the previous question, 2 to the 5 is 32. Let's compare this to our question. We have 1 over 32. So why don't we take 1 over 2 to the 5, as this will give us 1 over 32. So we can express 1 over 2 to the 5 as 2 to the minus 5 equals 1 over 32. And if we express this in terms of log, this will be log base 2 of 1 over 32 equals minus 5. And our final question, log base 5 of 1. Okay, so we know that 5 to the 0 is equal to 1. And when we take log of this, we'll have log base 5 of 1 equals 0. So, some key takeaways from this video. If we have n equals a to the x, an equivalent way of expressing this is by saying log base a of n equals x. Another key point is log base x of x is equal to 1. So, where did this point come from? Well, let's have a look at what we did earlier. So, we saw that log base 2 of 2 is equal to 1. Now this is true for any value of x. So you can see here that we had log base 3 of 3, which is also equal to 1. So hopefully you understand the basics of logarithms, and in the next video I'm going to be talking about the laws of logarithms. Bye!